Welcome, everybody. Welcome to the launch of Houdini 22. We're extremely excited to be here in London, England. Super excited. And the R&D team has been extremely busy for the last year, working on lots of enhancements and features based on your input and feedback. And to take us through that, Kristen Bargiel, our VP of Product. Kristen.
Thank you, Chris. Welcome, everyone. It's really wonderful to be in London again, enjoying the weather, enjoying a new release. Hopefully, you'll enjoy it as well. We have a really big show for you tonight. Houdini 22 stands really tall among all the major releases that preceded it. It's got a really hefty breadth of scope, a really aggressive, ambitious R&D agenda, and a clear, confident, and calm direction to get you through these big changes that are happening in this industry. And truth is, Houdini at its core has always been about this, right? Giving you that leg up, that ability, the confidence to go through any challenge in style. And that's something that we as R&D have been conditioned to do from the beginning. That's how we think. That's why you can trust us to always fairly aggressively assess new technologies and adopt them as soon as they're ready, as soon as they're a good fit for Houdini and for what you need out of Houdini. And so for Houdini 22, what we've done, we've really zeroed in on two groundbreaking technologies. One of them is Gaussian Splats. And the other one, AI? Good, good, good. Well, don't worry. It's all good. It's all good. So we're weaving them deeper into the software, giving you a smooth workflow that's also coupled with really game-changing functionality. So let's start with Gaussian Splats. So that one, if you recall, the initial release was in Houdini 21, right? And it was just a bit of a side tool, testing the waters, letting you visualize, maybe render a little bit of these splats, see how it goes. Well, a lot has changed in the past year. We've turned that little tool into a full-blown tool set that you can access throughout every point, every node of the CG pipeline. And it's not just this little read-only thing that you can visualize and render. And rendering is much better. Visualization is a lot faster. But we've added it as a core first-class citizen to Houdini. So there's functionality there that was not there before. You can create them. You can modify them, often in ways that we ourselves had not envisioned before. So make sure you watch throughout the presentation tonight because we've peppered the whole evening with Gaussian splats here and there, as some of the examples you see are bound to surprise you. Okay, next one is AI. So no panic. Don't panic. It's all good. It's all good. We are crossing this landscape and we're staying cool and collected about it in the face of hype and occasional panic. It's all good. It's all good with us, all right? There are really, really good uses for it in Houdini. And as we go through them and study them, we're discovering even better uses, ways that you can use AI in a very controllable manner, in a very customizable manner. So what we've been doing now in Houdini 22 in particular is looking not only at, let's call them business as usual tools, adding neural cellular patterns and whatnot. We're looking at how we can now integrate, big name third-party models like Detectron, SAM, Moge, and seeing how they can coexist with the rest of Houdini in this, what we envision to be a hybrid pipeline, right? Where you have the proceduralism of Houdini, interactive tools in Houdini, and then homegrown ML, and also these big name AI models all living together in the well-orchestrated node-based environment of Houdini. Okay, so this is all under control, guys. All right. Now, these strategic initiatives aside, Houdini 22 is a rich collection of milestones. And the first one has nothing to do with features and architectures and software development. It's all about celebration. So I am so proud and honored to tell you that 30 years ago was the first release of Houdini. So Houdini is now turning 30, and we are so proud and humbled and honored, like I said, to have been part of your lives and your careers for this long, and we appreciate the opportunity to continue to be that for many years to come. So thank you to all. Thank you. On behalf of all side effects. All right, the next milestone is KineFX. This is the umbrella project about everything character and creature, right? So that we've been investing a lot in, for the better part of this decade, in those tools, and this is the release to watch, because this is when everything is coming together in a state-of-the-art kind of fashion, and I'm talking about rigging, animation, retargeting, motion mixing, and if we allow to include CFX in there, muscles, hair and fur. So you'll be seeing a lot of that tonight. Okay, that's the first one. Second one is Copernicus. By golly, was that a woo? All right, that's good, that's good. So we are amazed ourselves how quickly that baby has just grown. In 2 short years, it's gone from, here's a little beta thing that we think will grow into something one day, and here we are today, and I'm calling it a major milestone. And I hope I'm right. I hope I'm telling you the truth, because first of all, as of now in Houdini 22, Copernicus is a full-blown texture synthesis toolset. Everything you should expect to have in a tool like that is there now. And on top of that, to complete the equation, you now have 2D and 3D paint. So that part is complete. Please go grab it. Tell us what next we should do with it. Second part is terrain. We've moved all of terrain, everything that was in SOPs, all the height fields into COPs for a 5 times faster performance and also a more familiar workflow. And that's terrain. So now Copernicus is that as well. We have new physics solvers in it as well to augment the ones that we released last year. And on top of that, this growing ML platform. This is the place that we see the orchestration of a lot of these AI models taking place. That's where the platform itself is strong, and that's where the meat is going to go on the bones. So let's see what happens, and you'll see later today from Scott how we're doing that in Houdini 22. It's definitely giving you a good insight into our plans that way. Then there's Solaris. Solaris is gaining its 3rd arm. And you might go, what arm, what third, why third? All right, so Solaris by design was supposed to have 3 L's in LOPS. Lighting, look dev, and what we thought would be called layout, which we understand had better be called set dressing and world building. So anyway, this 3rd arm is finally arriving in Houdini 22, complete with RBD support and Hydra support and all of those good things. So Solaris, and to Solaris, of course, you have Karma. You have that in one breath, right? You say that in one breath. So Karma is now a bona fide, mature renderer. It's battle-tested. It's being adopted a lot. It's adding a lot of value to Solaris, a lot of value to Houdini. Check out what's happening there as well. And then there's the whole Copernicus element again, which brings in all that really, really important and valuable tight loop between lighting, rendering, and compositing. So it's all coming together really well. That's why we consider that to be a big milestone as well. And then there's one final milestone. I told you, lots of milestones. So the last one is in the category of out with the old and in with the new. And we have 2 pieces in there. The first one, the 3D viewport. So the 3D viewport is finally completely shedding its old OpenGL mantle. It's now all Vulkan and Molten for those of you on the Mac. And this not only cleans up the code finally and gets rid of all kinds of bugs, it's also flinging the door open for us to work on that cinematic, near real-time Vulkan-based render that we've been talking about on stage for some years. So expect that to come in the future. And the other side of out with the old, in with the new, has to do with our UI. There might be some gasping in there in the audience. Anyway, I'm ready for all that, okay? I've been braving myself for this moment. So that one is all about our native UI being pushed aside, not all of it, most of it, and being replaced by Qt and QML. So that finally unfreezes, unlocks the capabilities that we've been dying to put in to our UI and also the UX. And please don't be mistaken, this is not just a pure re-theming of our UI. We drew some new icons, there it is, ooh la la, okay? This is very much a serious, long-term, arduous exercise in functionality that drives form, like everything else in Houdini. But with that does come a new UI skin. So if we're guessing correctly, this might be the big stamp that gives Houdini 22 its strongest visual identity. So to see if that's the case, allow me to invite Scott Keating to show us the new UI and then get us going on the journey tonight. Thank you. Oh, you don't need.
All right. Thank you, Kristen. Can you guys hear me okay? Thumbs up, okay. So yeah, the user interface. So this is sort of the first step, right? I mean, Kristen talked about a complete overhaul, but this really is first an aesthetic overhaul. It's the first step on this road. But it isn't just aesthetics, as he alluded to. So let's take a look at a couple of quick examples here. So first off, you know, a sort of a humble example, the start screen here, where you can choose the look of your user interface. This is now an interactive widget, which is actually a really nice thing because it means that over time we can update it with things like links to tutorials, start here examples like this sort of production set to get you going. So it's just a nice, smooth introduction to Houdini. We also have a theme editor, so you can change the look of Houdini using this nice interface here, using base, accent, highlight colors to change your theme really easily without having to tweak every single color in the interface. Of course, there's a whole suite of presets that it comes with as well, and you can tweak them, store these presets, create your own presets, share them, and so on. So this is hopefully going to open up things really nicely for changing the look. And again, global contrast slider to help depending on your workflow, if you like high contrast or low contrast work. We've redone the preferences. Here you can see a much cleaner layout, much better organized, much easier to navigate, and maybe most importantly of all, the fact that you can search the preferences, which is super useful because sometimes you know a preference exists and you just don't know which category it's in. Now you can go ahead and search, find that preference you're looking for immediately. Again, just sort of like small steps towards a much smoother UX for these kinds of things. Tooltips. Here's another example of how we can take advantage of some of this new technology. Tooltips can give you better context, show images, so that when you're trying to figure out how things are supposed to work, you don't always have to dive all the way into the help, although of course you can easily jump to it from here. As Kristen was talking about, Copernicus, Solaris, color is really important. So we've revamped the color picker to give you a much smoother experience, much better suite of controls. You can use, save your own palettes, store your own palettes, edit the colors using a lot of different methods. You can see the OKHSL down there. And of course, we have a revamped color picker that you can pick from anywhere in the UI, even outside your UI, and have a bunch of different options for picking your colors, like harmonious colors, complementary colors, or even blend between two swatches. So this just gives you a lot of better control, easier to pick the colors, and also easier to create these palettes and share them for any sort of production needs where you need to share those things. Here's another really great example where we've upgraded the ramp gallery, the ramp catalog, so it shows up in the interface. You're not just going by preset names. There's a full catalog of ramps that you can pick from for all your various needs. Again, all nice and visual, available for you to work with. You can also alter, generate these ramps. So here we're just loading up that ramp, And now we can sample it adaptively to sort of pick out the key colors so that you can reduce that number of keys on your ramp, make it easier to work with. Or you can actually directly sample, again, from your screen. So here we're drawing this curve. You can see the dots on the curve where we're adaptively sampling it to pick the colors, and you're generating a new ramp from those values. So there's a lot of other enhancements. You're going to see new port shapes in COPS, a lot of other tools along the way. So let's move on to our features. So I'm going to go ahead and ask Esther to come up on stage to talk about KineFX and APEX.
Yeah, thank you, Scott. So yeah, of course, we've been also very busy on the whole character realm. And if we think about the nature of what rigging actually is, it kind of sits between two chairs. So you have the static input coming from modeling, and then you go over to the big work beast, which is putting everything into motion with animation. So that means we need to have a very good communication connection to these other departments, both to the static modeling side, but especially, of course, to animation, which makes sense. So we want to make sure with this release that we get you from modeling to animation as smoothly as possible, and especially for standard cases, as quickly as possible. And we want to make sure that all the workflow steps there are very rounded and well connected, as we already said. So the big cornerstones here are rig templates, retargeting, and rig inversion to connect everything together. But let's think a bit about what we already said with Gaussian Splats. They are just nothing but another static input that we, of course, want to process when it comes to rigging, right? So we treat it like any other polymesh, meaning we can capture it, we can rig it, and we can actually animate it. And our workflows don't really have changed at all. So let's do this with this WASP. So we're starting simply with the rig builder, and we're just using some of the standards. So for the abdomen, we use a spine, then we have some eye case, and it still looks a bit weird, so, well, let's change that. And we do that because we have now shape LODs. That means you can switch between a proxy, a low-res, and even a high-res version of the G-splats to give you like real-time feedback when you interact with your WASP. We can do the same also for the controls. And now we combine our control configurations with our actual rig configurations to one entity and save it out. And that entity is a rig template. That means we can actually reuse the whole thing again for other insects. So now we're very happy. We have a flying wasp. We can animate it. Great. But you've already seen on the start screen that we have a few other insects that we might also want to apply this to. And those other insects might be not exactly the same as a wasp. So we're starting off with that little rhino beetle here. And you can already see our insect icon. We drag it in, and you instantly have the whole rig. Everything is already configured. Everything is adapted and mapped to the names. And we can directly continue. The nice part is the whole control configuration is also being transferred and stored along with it. So you can see our wasp icon there again. It's all there. So now we're going to the larva. Well, that one clearly has no wings, and the abdomen is absurdly long. Well, the template, actually, our rig template, still adapts though. So I can simply apply it. I need to wait for a bit. And these different joint lengths are being automatically detected, and certain joints can also simply be skipped. And because our template pretty much has all the features directly procedurally available, we can now change it. Because, well, we're not really happy where the tip of this abdomen is being parented to. We just quickly change it with our newly organized interface. And voila, we just changed the rig, applied it, and we're ready to bring these two creatures back together. Because, you know what? This is actually a rhinoceros beetle, and this is his massive larva. So mommy and child can meet again, all within a simplified workflow. And, well, we're not done with our beetle yet. So we want to change the look of the controls. And if you missed the style of the KineFX controls, well, it's back, because we now have image controls. And they can actually even scale with the viewport if you want to. You can choose your own images. And there's a few other goodies that actually come with it. So look at this arrow. So now it's going outside of the screen, but maybe I really want to pay attention to that one. And now it's actually being kind of like glued to the screen, always available at reach. And that one is one of my favorites. I'm using now an abstract control, and that thing actually, that little balloon icon, acts a little bit like a viewport gadget. It just stays in screen space. You can even do the same with transform controls. that all of a sudden opens up a whole world of like control widget designs that you can do in ArtDirect that hasn't been really possible before. And well, as much fun as it is to build beetles and larvas and insects, we know that in practice, very often we actually need to build other things, primarily, of course, bipeds. And we want to be ready for that action for you as well. So for that, we are preparing for you, or we have prepared for you several recipes, and of course the rig templates that we just introduced. So now we start right away with one of those recipes. We just plug our geo and the skeleton in, build a full biped with everything that you need, and we can continue to modify it because, well, now you can just go custom from that point on. We have like a fully redesigned and organized interface in the viewport ready for you that guides you along the way. So if I now turn the mirroring, for example, of the arm on or off, the viewport guides you along the way. You can, of course, add features to it, remove it, change it as you go along. Another important point is that we also have now auto-aiming for joints. That means that should you need to change the positions of your joints, it's often a lot easier doing that with translations instead of rotations. So we can actually help you along the way, making sure all of that is conform. And of course, we don't just want to make the experience of the character setup more convenient. We also have the animator in mind. So we have procedural selection sets ready for you. And you see that interface again for the LOD switching of the controls. It can actually do a few more things. Usually you have a lot of configurations that you have per body parts, and we can nicely organize them now in that one always screen-facing interface where everything is like neatly organized from you. And when you're done, you just collapse it and it's out of the way, and everything is a bit neater for the animator. Next case, an FBX. In this case, I want to take an FBX from Mixamo. So there's a really important thing when it comes to Mixamo. Mixamo skeletons have completely different naming conventions and completely different joint orientations. We can still fully adapt a biped template. In this case, it's a simple biped. Well, and it just works because we have a nice mapping prepared for it. You can also see this here. See what happens here? We are actually conforming the orientations and the names to our standard biped. Why is this important? Think about your poor animator. If you just really quickly need to assemble your scene and you have skeletons from 5 different sources with different names and different orientations, the animator has absolutely no chance to know what to expect and where to find it and how things are oriented. In this case here, with the conformity, we can bring 2 characters from very different sources and worlds together. Everything behaves the same, and this is, of course, the standard and convenience that's important for your animator, and it's even also important for the stability of the rigs that we are generating. So we're good on the biped front. We can quickly create them. We have conformity, but sometimes you want to add a few things. And we decided, well, to add a lot of things. And with this, I present to you Cedric, Lord of Chimps. And we simply wanted to see how all our different, well, character setup, animation, also CFX tools all play together for a character with that level of complexity. And so here you can see what the animator would see. This is actually a play blast from the animation side. And we are combining here so many different things. So we're using the rig builder, we're using the fuse graph, we have blend shapes in there, we have the wrinkle deformer in there, driven keys, we have a custom setup for the armor for ragdoll and custom setups for the armor in general, and many, many more things for you to be ready to be discovered. And they all play procedurally together. And that also means you don't actually need to look at a graph to create all of this. This all just uses the elements we have and elegantly combines them to that kind of a level of complexity that we are after. And here you can see Cedric with a nice render, of course, as well. One of the things that we do want to highlight for this is the facial setup. And here, in terms of deformation, we're simply combining normal fax blend shapes with the wrinkle deformer. That comes with the advantage that you, of course, have nice control because you're working with fax, but you save yourself a lot of granular detail that you otherwise need to sculpt in because the wrinkle deformer takes care of it. And it doesn't just take care of it, it also breaks it up for a more non-linear look, which really helps you and might even save you a lot of in-between shapes. For the interaction, we have now this nice 2D interface, remember 2D controls, our controls are actually kind of shapeshifters. You have this 2D interface, but you also have the sliders that are directly on the face that we're going to see here again. So as an animator, as you animate, you can go back and forth, switch around as you need it, directly in the shot. These controls do both, and it is exactly the same controls, by the way, that we are just switching the look of. Other than that, of course, we also had to open and close the wings, and for that we used set-driven keys. This pretty much just dials in an animation on top of our joints and controls, but our controls are not locked. We can still fully animate on top and tweak the shot based on our current needs, so it simply gives us a nice guideline and standard, but it is not a blockade of anything in terms of animator freedom. And we can enhance that effect a lot more in this example. So mechanical setups are actually a perfect candidate when it comes to set-driven keys, and also multi-eye case with constraints. Constraints are very often very important for robotic arms. Same goes for these effects where you dial something in and a few elements plop up. This is usually set-driven keys. And we get that wonderful haptic effect in this example simply because we use skin controls, which we actually already introduced earlier, which allows you to select direct surface elements to interact with them. So let's see how we're actually getting these driven keys together. The major, workhorse behind this is our new APEX rig pose node. That node is pretty much doing anything in the animation and posing realm that is important for animation. That means be it an update of your rest pose or creating animations for rigging for both controls and joints. In this case, we want to change the animation of those flower petals. So we just grab them, and of course we are like in the animate state. We have exactly the same tools available, so we just quickly change them. How can we organize them? Well, in the animate state we have animation layers. They're perfect to just bundle the animation together and give it a nice name. So of course now we want to continue and turn it into set-driven keys, and the set-driven key component is the best friend of the rig pose node, so they work really well together. All we need to do here is to define, the range of the animation that we want to have, and we need to give it a driver control that we define just to associate it with it. That's all you had to do. You didn't need to look at a graph, and you have a very intuitive back and forth. And because it's a two-node setup, we also wrapped it in a nice convenience recipe for you so that you can hit the ground running and that you can build your own mechanics and wonderful setups out of it. Well, but sometimes you still want to look at graphs because you do want to build something that's a bit more out of the box, so we also want to make sure that you're covered there. So we're introducing now the first steps towards an APEX debugger. And that might look like something very simple, but you can now look at your graphs at the kind of like numerical output of what happens in the viewport. So we see, something's obviously not right with our fan, it's not opening properly. So we check for the numerical values on the hover text, and we see, oh, it's just 45 degrees. That's wrong. So let's change it. We set it to 180. Voila, the fan is opening. We are happy, and we can also numerically confirm it. And this closes exactly this loop for better customization and building really wild things. Talking about wild things and crazy things. Sometimes your director wants you to build something like this. And this is the moment where you sit there and, you're a bit unhappy because you think, maybe I need to now sculpt every single frame. I don't know how to do this. But you know what? APEX has you covered. And we collaborated here with the wonderful folks from Tumblehead to bring exactly this to life with APEX. So let's see how they're getting started. So we're starting with a clump, and we're pretty much starting with the default procedures that we're having. We're having capturing, we're having normal components, and then we just layer on top. And the folks from Tumblehead built a lot of custom deformers, all with CUDA, and of course we can simply connect it in because the HDK is there. So you can do all of this. These deformers are real-time, and you can see how beautiful they just fit into the whole APEX animation workflow directly. The other wonderful part about this is they're also operating always on character in, character out. Who says that if you do these operations that you're just changing the rig? Why not just add another set of arms? Or, add a lot of eyes? You can pretty much go fully wild there. And that level of flexibility is just pure magic. And we have here, of course, in order to achieve this, a whole bunch of wonderful HDAs that are being assembled, but under the hood, they follow pretty much the same principles of what we are doing with our rig components. Everything is glued together. Also these like cool shrink wrap custom deformers, they're glued together using APEX script. So we also wanted to make sure, so both Tumblehead and us, we both had a very strong interest in making APEX script also more convenient. But before I'm going to continue on that, we of course want to see the frog, right? So let's have a look at that beauty. His name is Hank, by the way. And yeah, I still think this is just incredible. Yeah, and that is, of course, the level of customization and craziness that we are after. And you can see APEX has you covered. And you can really push for this. So, yeah. So, I already mentioned that APEX script is something that we also wanted to push. And we wanted to make sure that we can also increase productivity here and make your life more comfortable if you do really want to build something wild. So we built the APEX script comfort package. This is a sneak peek of it. And you will potentially later find it in labs, but it's very exciting. So what we're doing here is we're pretty much providing with VS Code an extension for autocomplete. We are extending that. We're extending this as a Python panel directly in Houdini. And it also comes with an APEX script MCP server. So that means that the MCP server pretty much communicates to a very well curated library. That library has all the information that you need to write good APEX script code. It knows about the syntax, it knows about style guidelines, it has higher level examples, and it has a ton of granular snippets that can be simply searched, put together, and all of this is built in a way that is highly token efficient, and you can connect to, of course, with an LLM to it, and use this to generate now your code. It also comes with a validator to make sure that everything really properly runs. So now you can use natural language and ask it, well, hey, can you please change the color, or in this case, can you please build me 6 splines, make them S-shaped? And of course, it can do that because it knows how to implement a spline, it knows the correlation between joints and controls, the syntax rules that go along with it, and so on and so forth. So we can now communicate in a much easier way and get actually very beautiful presets for proper rig components, or to be honest, any other APEX script code that you're after. As a result, we now have over 300 lines of an actual fully functional rig component with high quality code standards, not just any gobbled up stuff, it actually really follows good examples. And at that point, of course, you can now customize. Or you can customize and then ask a few questions and get help. Or you simply use the MCP to get more knowledge about certain functionalities. How do I implement a lookat? Just ask it, and you're very likely going to get a good example that you can use as a starting point. In the end, it's just a snippet that has been generated. You have no further LLM dependency, so you have the full ownership of the result. And that, of course, increases productivity, and we are very happy about it. He's very happy about it. Well, he's actually very happy because he's got some body motion. And that brings me to, the next very important point that we want to talk about is we've seen now all the great things we can do in the character setup world, but we also still want to sometimes, or even in a lot of times, transfer animation from mocap data over to our character. And we put a lot of love into making sure that you're, especially in terms of bipeds, very well covered. And then you can retarget this one or all of them, and you can do all of this with the following workflow. So we have a recipe ready for you and a bunch of nodes specifically for biped retargeting. And the cool thing about them is they take care and they automate all the steps that are usually very cumbersome. One of them is the mapping of all the joint names to a given standard. This is auto-detected for you. So you don't need to do a single thing. It usually just finds the given standard and applies it. Same goes for rest positions. They're also being automatically derived from your skeleton, and you can directly focus on what's actually important. And now we already have a Mixamo character, and we switched from that one to Electra. You know why that is possible? Because we have this auto-detection, we can also switch over to different orientations and different names. And now we also want to, of course, see how flexible and robust it is when it comes to different proportions. So we switch now from this mixer mode character back to the mad villain, this dude. Again, completely different joint names, completely different orientations, completely different proportions, and the same setup still holds up fairly robustly. And we have here a nice lineup again of these different characters and the retargeting results that we're pretty much getting out of the box. And the exciting one to point out is our little blue blob at the side, because that one is technically speaking not even a complete biped. It is clearly missing a head or a spine, but the retargeting biped setup still works actually on it. So this is all great and good. So now we are happy, we have a setup, and we have skeleton animation. But there's a problem. We need to bring that animation from the skeleton back to our rig. And that process is called rig inversion. It's something where you just expect it to work, but it's not always really good to get good results there. And we want to make sure that this process is solid for you. So we put a lot of love into that as well. And here you can see a few examples of that. So we start with Electra's kick again. And now we're a bit mean with the skeleton. We're breaking it on purpose. And we're just crazy extending the leg for an accelerated kick. We switch over to rig inversion, and it's doing something that actually is completely plausible. You know what it's doing? It's measuring the distances for a leg, and that makes sense. We're just dialing in stretch automatically. And that is the kind of like custom solution based on these cases, or like custom rig inversion that we can now ship with our rigs, that gives you the freedom to get actual good, reasonable results when it comes to this. Another typical problem that you have in retargeting cases with mocap data is that you have, unfortunately, very flexible athletic people for your mocap shooting. That means you get these overbent legs. And if you're a mocap artist, you know that you're in trouble now, and that this will mean a lot of cleanup work. Because usually, IKs tend to flip. But and here you can even see it, we just use the leg, flip, flip, not great. That means you need to counter animate and need to go away from your animation. But we have now rest twist, which counters that, and it just gives you a result that simply works and counters the twist and saves you the cleanup work, and you're actually staying a lot more true to the actual capture. And if you still don't believe me that that's a problem, look at that unhappy frog. That doesn't look fun. So we turn it back on, and what we can do now, we can actually break IKs on purpose as an artistic choice. And that is something that, of course, gives you a lot more flexibility. So we see we're just avoiding the twist elegantly directly in the solver. So let's see now that we know we have all these elements, how they actually play together. So in this case, we just want to test the connectivity, because I told you we want to go through all the steps in an elegant way. We start setting up our character, brute in this case, and we simply apply the rig based on the template. And voila, the character is already set up. We have a functional rig. That was fast. So let's continue directly to retargeting. We connect it up. We just need to adjust the name, and we can already focus without any cumbersome steps directly on the important points, which is, well, obviously bringing in our animation, and making maybe some tweaks because we don't really like the look of the shoulders. We make the offsets. And we are maybe already very soon happy with what we are seeing there. So the steps already just now from having no character at all to having a retargeting result are really great. Now we invert it. Nothing more we need to do. That looks great. And the next plausible step would be to go to the motion mixer. And you see all these recipes are built to work together. All these nodes and steps are there to bring you in less than 5 minutes from no character at all to a character with retargeting data in the motion mixer. And now you can, of course, procedurally change anything within these steps. You can go back and forth. You can now layer animation on top. You can shuffle it with various retargeting clips and so on and so forth. This means full proceduralism with fast workflows to give you exactly a chance to really focus on quality for results like this. And of course, now we want to hear a little bit more on the animation and polishing side of things, from motion mixer to any other animation workflows. And that brings me to Warren.
Thank you. Thank you, Esner. All right. So we're going to begin with speed and how important it is for animators, not just for posing their characters, but also for playback so that they can see their animation in real time while they're working. And here I have 5 characters playing back at 24 frames per second, but what if we had 10 characters, or 15 characters, or even 20 characters, all still playing back at 24 frames per second? We can even go in there and we can open up a new viewport. So say we wanted a camera view. Still, everything playing back at 24 frames per second. And the way that we're able to do this is we have an option in there, and that option is evaluate rig in parallel. Now with this on, this is essentially just taking the characters and allowing them to be evaluated on their own separate threads. And these are the full Electra rigs here. These are not crowd agents at all. So I can go in there and I can animate any single one of these characters. So if we want to take a look at these 2 characters in here, I don't need to turn off anything. I can start adjusting the animation. So say I want to make them look at each other while they're passing by. We can easily do that, again, without needing to turn off any other characters, still maintaining our performance, still maintaining it playing back at 30 frames per second. So again, this is 20 Electra rigs in there. That's over 3,600 controls and over 13,000 channels, all playing back in real time, which I think is pretty impressive. Now let's talk a little bit more about the motion mixer. So you went through it all, you've retargeted your animation, you've set your keyframe animation clips up there, you've started cleaning it up, tidying it up, and now we can start using those clips to build more animation. So we can just drag those 2 clips into the timeline as you see, we can start trimming it, we can start lining it up, we can go and match the joint so it's all aligned properly. And now if we want to, we can drag it over, start blending it by overlapping them a bit, or drag the other side out and start cycling the animation. So really quickly, we can take these animation clips, we can play it through, we've created some new animation. And so I've just continued on here by adding another animation at the end. In this case, it's just having Electra stop walking. I've also added a couple of effects in here, a smooth effect going on. And if I'm happy with this, well, we can use a new feature in Houdini 22, which is called nested clips. And now what this will essentially do, I don't need to look at all this information anymore. I have it already there. So what this will do is combine it all into one simple clip. And you can see here, we have one called a nested clip in there now. And now you can see, simplifying my workflow, I only have one thing to deal with now instead of a whole bunch of things. But if we want to, at any point, we can still go in there, double click, drop down, and we have all of our information in there still ready to go. But again, we don't want to deal with all of this information, so let's just go back to our single clip. And so now we can move it around, shift it, adjust it without worrying about how everything's aligning, everything's locked in there. And if I want to use it again, I can just drag down that clip. And now I have it ready to go to continue building animation. And so if I want to do something like Electra walking, then going, stopping, turning around, and walking the other direction, well, all we need to do is add a transition clip kind of in between here. So we have just a clip of Electra just turning 180 degrees, and we do exactly what we just did. We just start lining it up. We can match the position of it so that the character's all attached, and now we have the character turning around. And again, since we now have this nested clip and it's so simple with just one, I can go in there and I can start adjusting it and adding it to this animation. So we can go in there, we can start trimming this clip if we want. We can adjust where it is, line it up. And in this case, instead of just matching the position, we've turned the character around. So we want the orientation to be facing the correct way. So we'll use match all in this case. And now Electra is facing the correct direction. So again, really quickly, using the nested clips, we've been able to simplify our workflow, be able to bring them in, reuse them, add a transition clip in between, and now we have a brand new animation of Electra walking, stopping, turning around, walking the other direction. And we could make this into another nested clip if we wanted to, so we could keep on building it that way. And here's a perfect example of it being done in production by Saša, using the nested clips, using multiple tracks and blending it all over there. And now we can see the amazing result that ends up from that. I always love Saša's stuff. It's so good. And just to note, end-to-end, that was done entirely in Houdini. So great work by Saša. Okay, so let's talk about another new feature we have in Houdini 22, which is a new APEX character picker. And so if we wanted to see how we could start using it, well, the first thing we want to do is just add a new tab in here. And we can rename that, and now we have a brand new canvas to use. So what we want to do is add some backgrounds to it. And we have multiple ways we can do that. We can right-click, you can add your own image, you can add an image from the viewport, or we can use one of our pre-set templates that we have included with it. So we can just drag this in. And if I wanted to, I can add something more in here, like hands or something. But I'm going to do that in a different way in just a few moments. We can also go in there, we can add some labels and text if you need a little bit more information for the animators. And once you get this, you can have your background, you're in a good spot. We can start taking a look at how we can adjust, add buttons to our controls. So down the left side here, you can see we have a bunch of preset buttons ready for you to go. And what we need to do, select our shape, we can select our control, right-click, add button. Simple as that. Now we have a button for that control, and it's going to be based off the name of the control, and the color is based on the color of the control as well. So you can see we have it here. We can hide the name if we wanted to after. We can minimize the size of that button. And if we wanted to, we could just go in and scale. So lots of options for how you want to set up your buttons for these controls. Now, what we can also do, instead of doing it one at a time, we can select multiple controls here. And we can right-click in there, and we can go in, and we can add button per control. Now we can just draw it out, saving us time instead of doing it individually. We can do the exact same for the legs if we wanted to, so we can select the leg controls here. And I'm going to switch it to a circle. Now we could do the same thing, right-click, add button per control, drag it all out. Our legs are now done as well. And I could do the exact same for the other side if I wanted, but instead what we can do is just select all these controls, and we can right-click on there, and we can mirror these buttons. So now these will be, of course, mirrored based on the names, but also the color of those mirrored controls. And finally, one of the things I use all the time is selection sets. I use it all the time for doing my animations. But now what we can also do is use these selection sets that you have, and you can right-click in there and add a button per selection set. Now you can have a nice, clear visual way, labeled properly, to be able to select your selection sets very easily and start using them just as you normally would. Now, I mentioned about the hand earlier, but instead of putting on this canvas, what we can do is we can split the view top or bottom. And now we have a nice big clean view, new canvas, but under the same character picker. And we can start building it up so it's a little bit clearer for all the selections, the character picker buttons we want for the hands. So we can do the same thing, just select the controls, we can add a button per control, just draw it right out, and then we have it. So let's take a look at one that I've previously done here. And you can see we have all the Electra picker all set up there. If we look at the bottom, we have our hands and our feet that I've set up there. But what we also can do is go to the right, and I've set up a ragdoll picker for the character as well. And this is really great because essentially when you're using ragdoll, you're interacting with the collision shapes. However, when I'm doing ragdoll, I don't like you looking at the collision shapes. I'd rather look at the skin shape. So now we could do that, see the skin shape with ragdoll, but we still have the character picker ready to go, easy access to all those collision shapes that we have in there. So it's a really great benefit to, again, do that, but still see our character skinned while working with ragdoll. And of course, multiple characters, you can have multiple pickers in there. And for Houdini 22, when you drop down an Electra or an Auto, included with them will be these new character pickers. Also new in Houdini 22 is the ability to use cameras in APEX. So here, we can just take a look at this. I've added a shot camera here. And this is a dialogue shot that we could take a look at. So we can open up our audio panel. With scrub on, we could see where we can load in our audio file. So now we can put that on, start working on our facial animation.
Welcome to the Gunpowder Cafe. What?
And so when doing facial animation or lip sync, it's really a good idea to have a nice clean viewport with the face very visible. So we can open up a new viewport here, and all we need to do is switch this to a face cam that I've set up. And this is essentially just a camera constrained to the character's head. So now we can get rid of that body motion so that when we start playing this through,
Welcome to the Gunpowder Coffee.
or scrub it,
Welcome.
we have a nice clean viewport so we can focus on the face doesn't matter what the body's doing. So now we can take a look at this. We have it all nice and big. And as Saša showed earlier with the facial rigs on the chimp, well, we can just turn on our controls and we can have them directly on the character's face. So we can start just grabbing them, posing them just as you normally would. Or we have a few other options. So if you want to, we can always go in there and we can put it on so we can see the limits of these controls, how they're going on, if we want a little bit more information. But again, like the chimp, we can always go in there and we can take a look. In this case, the box layout, which is an early prototype of what Esther showed. So now here, we can go in, allow the animator to decide how do they like to use it. Do they like to use the box layout? Do they like to use it on the face? I prefer the box layout. It just keeps it a little cleaner for the face while I'm posing things. And now you can go in there, start posing your animation, doing all your facial and lip sync you normally would. Or perhaps you already have a bunch of poses set up in your animation library. Well, we can just use that as well. So we can go in there. If we had some eye shapes that we wanted to use, we can just click on it. And you can see when I click on select controls, it selects all the controls in the viewport. We can dial it on as much or as little as that pose as we want. Or maybe we want to do something with the mouth instead. So we can go into the mouth, select the shape that we want to do. And in this case, I saved all the controls out in this pose when I saved it. So you can see it's selecting everything, and when I move it, everything's moving. But if you just want the mouth shape in there to be moving, what we can do is just select the set that we want for that. And now when we dial it in, it'll only dial those controls that are included in that set. So lots of new ways that you can start working with face cams and doing your facial animation and lip sync shots. Also on this, you may notice to the right-hand side there's a lot of layers put in there. And this could be generally okay if you want, but this being animation, we get changes all the time. There's always something that's going to change while we're working on a shot. So in this case, say they delayed the audio by 10 frames.
Welcome.
Well, now nothing's lining up anymore. And previously, this would have been a little bit tedious to do because I'd have to go through each one of those layers and adjust them one at a time. But in Houdini 22, we have a new thing called geometry channels in there. And this allows us to have easy access to all of our animation layers that we want. So we can select whatever we want to go in there. In this case, I'm going to select all my layers, all my animation for the character. And we're going to use another new tool we have in there, which is a retime tool. So with this on, we can just double click in there. And now by grabbing the thick part of this handle, we can really easily offset all of our animation, all of our layers.
Welcome to the Gunpowder Coffee.
And so now everything really quickly, we've lined it all up, we're good to go again. But let's talk a little bit more about these retime tool because there's a lot of really cool features that we can go in there. So say there was another change. Say after you said welcome, we needed to go in there, we needed to have a big pause and they wanted something to go on there. So we can go onto that frame, we can double click in there, we can drop down a marker, we can drop down another one. And if you make a mistake, it doesn't matter because you can grab the thin part of the handle and we can adjust where that is without moving any of the keys. Once we're happy with where it is, we can just grab the thick part. And now quickly, I can shift all that animation, open up a spot in there, but keeping all the animation as is. So if we want to, maybe there's another thing where we need to speed up our animation. So we could drop down another marker and we can compress it there. And you can see how we can speed it up. But again, all the animation, all the keys outside of it are remaining the same. So there's lots of new ways that you can go in there, really quickly use these markers in the retime tool to start adjusting your animation, your keys, and your curves really, really quickly. All right, let's talk about full body IK and how we can use it to change animation without dealing with all the keys, all the curves, and all the controls that you have on a character. So if we jump into here, what we can see, we have our bookmark down at the bottom, and we can just control drag on this, or if we want to, we can just type in the frame values in the parameter there. And this is going to be setting our range that we're going to be adjusting the animation in. So to do this, it's very simple. We just select a control. In this case, I'm just having the head. We hit H, it gives us a target. We click on this pin button. And now what this does is sets our in and out points based on our bookmark there. So if I want to do any animation change, say I want to make a lecture look over. Again, I just need one control while I'm doing all this in full body IK. Now we have it. We have a lecture walking, looking over, walking back. Everything outside of that remain the same, just using our change inside. And I can go and do another adjustment in here. Say I want to have her looking up while she's walking. Again, just using one control, quickly changing the pose. Now we can go in there, change all that animation as she's walking, looking up, and continues to walking. But maybe there's something that changed. Maybe now we have to have an axe swing at her head. And we don't want her to get brained by that axe. So what we can do is just go in there and we can just adjust with one control, again, moving her down, just making her duck right under that axe. So really easily, we can get her, pose it, fix up that animation, change it now with just a couple of keys in there. And now she walks under, just dodges that axe. But you can see that hand, the back hand's kind of distracting to me. So at any time, we can still go in there and still adjust more things. So I can select that hand and I can hit H to make it a target. And you can see it goes back more to its original animation. So now we can have that dodging from there. And again, we can continue going on, doing as many animation changes as you want in there. So we can also go in there, use our animation sliders. These fully work with the full body IK as well. So I can start doing breakdowns and in-betweens all in there very quickly, just using the sliders. And so now we have it all going, but we can do one more thing where we have even more control over there. And we have a weight parameter over here. And when we dial that in, we now can control how much or how little of that full body IK is being affected in there. So really quickly, a great way to be able to quickly change animation without dealing with all the controls, curves, and keys that originally made it. And next, let's talk about a skydiver and some pretty rough animation here. Now, instead of me going in and having to hand key all this animation, fixing it all up, we'll take a look at Ragdoll and one of the new features we have in Houdini 22, which is forces. And so here I can click on the forces icon, and what it'll do, we can have 4 new forces we can use. So I'm going to start with wind. So I can just drop that down. I have a control here now, and I can just point it up at the character, and we now can see a lecture reacting to that. So we can go in, we can increase the strength, and now we can feel like she has maybe a little bit more air resistance as she would be plummeting to the ground. We also have turbulence. So now if we add this on, you can see we're getting some random motion in there. But look at that head. The head's flopping around a little bit too much. So again, we can use our character picker. I can select just the head collision shape. And now the beautiful thing about these forces that we have in there is that they work per collision shape. So now I can just dial down the turbulence of that head and leaving everything else the same. Now we have a much more stable head. We can do the same thing for the legs here. We can just dial down the turbulence on it and start really correcting it. So per collision shape, we can have total control over it. We can also try a magnet here. So I'm actually going to just turn on the display so we can see it pulling. You can see it, as we move it around, it's pulling, pushing the character around. So you can almost start sculpting the pose based on this, just as you pull and tug it away. And if we don't want it at any time when we disable it, it'll turn gray so we know it's no longer active. And finally, our last one is dampen. So we could take this one of going with a more high-frequency character plummeting through the air, and when we increase it, now we can feel like she's almost floating in water instead. So lots of options, lots of ability to change your forces per collision shape. And even if you have no animation, say we want to do those car salesman inflatable things, we can go in there. We can just have the character falling. We can turn on some magnets, start getting it moving. We can go in there. We can change, add some turbulence for variety. We can add some wind, getting their arms all in there. And we can even go in there and dampen just the front 2, leaving the other ones around. So again, without any animation at all, really easily to use these 4 simple controls to start getting some new motion. And staying with Ragdoll, say we had a shot where a lecturer is smashing another lecturer through a table. And in Houdini 21, we introduced the way that we can take prefactor geometry into our CNAD prop node and then use that in Ragdoll so we can do some simple destruction. So here you can see I just have something set up, but I haven't started anything yet. So the table just falls apart right away. Now previously, what I would have to do is select all these points and I would have to manually key when that Ragdoll becomes active when the lecturer is going right through it. but now we have a really great new feature in Ragdoll called impact threshold. And this is based on velocity that we can dial in with just this little slider. And then when we click it on, now we can just use our impact threshold, and I don't have to manage when things happen. So now we could just play it through, and now the table only smashes when the lecture is getting thrown through it. So this is, again, really great, because I don't have to manage when things are being active. We can rely on impact threshold for that. And we could do the exact same thing if we wanted for Electra. So we could just turn her on to use the impact threshold, and now she'll only go into Ragdoll once she hits that threshold. So we do this, we're all happy, we go out, and we're like seeing our original animation. We have our Ragdoll layer that we baked out, breaking through. But again, this is animation. We're going to get notes, we're going to have changes. So what we can see here is I can just duplicate the layer, so I can work non-destructively on this. I can then select all the controls on it, and we can move it. And so if we wanted to keep this character up, 5, 10 frames longer before smashing her through the table, we can go in there, we can use our animation sliders, just start posing, animating our character, delaying how long it takes she's up in the air before she gets thrown through. And I've just created another layer here, doing that exact thing. Now she's being held up a little bit longer before thrown through. And this is great, except that we now need to do our Ragdoll again. Now, the great thing about this is that I don't have to do anything here. Impact threshold's on, so basically it'll take it over. So even with my delayed animation, my changed animation, I don't have to manage anything. The table will still break, Electra will still turn into Ragdoll once it hits those thresholds. So again, it's just a really great tool, so I don't have to deal with all that. And we can go in there and we can still do things like making the table stiffer so she doesn't break through it. Maybe we go half and half so she kind of breaks through, or we go in and now she gets slammed right through the table again. So lots of really great feature, spending less time managing things and more times animating. All right, so let's talk about G-splats and how we can use them in animation, more than just a background. So because G-splats can be lighter weight than meshes, especially for a complex scene like this bar scene, what we can do is throw a lot more of that data onto the GPU. So now we can use a G-splat, put our character in there, start working with it like a set. And we could do more with this because, again, G-splats are essentially just points. So we can start selecting points of this G-splat set. So in this case, I'm just taking the stools here, taking those points and removing them from the scene. But we can do even more, because now that we have those points in there, we can plug that into a scene add prop node, and now we can bring them back, and now we can have controls on them. So now we're bringing it back into Animator's world, where we can now just pose the G-splat stools just as we would with anything else. And so now we can take a look at it, because we don't want it just to be a static set that we work around. We want to be able to interact with this thing. So if we wanted Electra to go in there and kick these stools over, well, now what we can do is use Ragdoll. And again, I can just set my impact threshold on it, so I don't have to manage any of the activation. And now Electra can interact with the G-splat stools. And since we could do that with props, well, of course, we can talk about the G-splat wasp that we have. So here I just have a very simple animation on one control, moving the character around. But instead of me going in and hand keying all the legs, all the antenna, we can take a look at a new feature that we have, which is secondary motion. So now with this in there, I have my antenna selected and we can play it through. Now you can see we're getting free secondary motion based on my simple animation that I had on the one control. Now, what sometimes happens with this kind of stuff is you can end up with a lot of twinning motion if it's the exact same values. But the great thing about secondary motion that we have is it acts per control. So we have these transform multipliers up there that I can just start dialing it in. So I can start getting variety, get some differences in there so it doesn't feel like they're moving the exact same way. And we can go in there, we can select more controls if we want. I can select all the legs here. I can select the abdomen and the head. And we can continue on just with the exact same settings here. I can hit enter. And now again, now we're getting some free motion, secondary motion, just based off, again, that one simple animation that we had on the one control. And we have we have a few different effects that we can take a look at. We have lag overshoot right now. We can take a look. We can add jiggle onto it. You can see it behaves a bit different. We have more parameters there to be able to adjust. And we can look at spring as well. And you can see, again, we're getting a different result based on what our effect is. And finally, we have one more thing that we can take a look at, which is our blend here. And what this is more than just blending to lessen the secondary motion. What I can do is actually use it to go from secondary motion, blend it right into keyframe animation. So here we can go a secondary motion, blending into the keyframe animation. And then what we can also do is we can splat that G-splat wasp using ragdoll with it as well. So I think you can see that there's a lot of opportunities in here that you can start working and animating G-splats with Houdini. And with that, I'm going to pass this now over to Kai to talk about CFX.
Thank you.
No worries.
Hey, friends. So we'll talk about crowds first. We have a lot to get through, so I'll jump right into it. You've seen these guys before. There's really nothing new and special about these, just these guys going into ragdoll mode and flopping about a bit. But the new bit is actually related to this, to the ML deform that we introduced on Auto with the last release. So you can see we're swapping it in and out here, and you can see the deformation improving quite a bit. So this is the trained ML model. And the new bit in this release is that we can now apply this to crowds. So we can apply this to agents. It's just a viewport option. You just turn it on and you get the nice deformation on these characters. All on the GPU, you know, baked down to blend shapes as it was before, just applied to these agent primitives. We can see that running here on Capybara. Again, the deformation improves quite a bit. It's a really efficiently trained model done with the armature deform. And it's running on, I think, 50 capybaras here. And the way that we can do this is the model itself is actually very light, right? It's just doing inference on the blend shape weights, all baked down blend shapes. So we're actually batching this inference across multiple characters because a single character is actually way too small to just actually saturate a GPU that we have these days. And another component of this is the agent LOD reduction we have now. So that's a slider that you get in the viewport options where you can choose between, you know, a balance between performance and quality. So higher quality basically means more of the closer to camera agents will receive the full stack of deformation with the blend shapes and the ML model. Now before we jump into some of the muscle improvements that we have, I actually want to point out and circle back to the rig improvements with these 2D controls. We can switch LODs on rigs, but one of the LODs is actually the bone geometry, which is very useful to look at before you go into CFX simulation, right, to ensure that everything is like intersection free as much as possible and working correctly. So that's really useful to us in CFX. And then with CFX itself, with our Otis setups, we have quite a few improvements to the muscle transfer recipe. One thing that you asked all of you asked us right away as we came out with this recipe, well, how do I get my animation into this? Because everything's kind of ready to go, right? You've got your transferred muscles and everything, and this was just a sort of missing piece. It was actually fairly difficult to solve fully procedurally in the past release, but with the biped retargeting tools that we have now, it was really straightforward to integrate this in the recipe. And then, the main benefit of this is we have, of course, the kind of mirror recipe of this, which is the simulation. And this now has the exact same nulls as input that we have as outputs from the muscle transfer, so we can plug that in directly. So this enables CFX artists to test their setups much more thoroughly, right? You can plug in mocap animation before you even get like a fully approved rig out of your pipeline. And now this example is not actually using muscle transfer. It's a test that we did with custom modeled muscles on Brute, where we try to simplify a bit, get an even more efficient simulation, combine some of the muscles you can see here on the delts. Auto has the 3 heads separately, and then we have a bigger single blob on Brute. And yeah, the solver works really efficiently with that. We get really nice results from it. Of course, this is a fairly long, actually kind of challenging animation, right? Fairly extreme deformation, but it all works nicely. And this is it with the thing that Esther was showing before, the full tissue simulation on top. Now, the reason this runs so smoothly and without really any issues is some underlying improvements that we have in the solver. The vertex block descent paper that we initially based the solver on actually has some inherent flaws with the way it does damping and constraints. So with high stiffness materials, it can actually dampen some of the global motion. So if the character is just like moving through space, the muscles and tissue would lag behind a bit. So we have a new constraint formulation that just applies along the constraint gradient, which is very similar to the XPBD damping we do in Vellum. So you can see here at the bottom right, that's a fairly stiff material, but it's not damped overall, right? The motion of it falling is working as you would expect. Another thing we brought over from Vellum is velocity blending. So that's an idea that helps the solver lag behind even less without requiring excessive iterations, right? As you get very fast motion, we blend some of the velocities, some of the inertia that we get from the bone animation onto the muscles. And then as they slow down, we fade that back out. You get the pure simulation, and you get all the benefits, all the jiggle that you actually want from a muscle simulation. Another thing that you've asked us for is more customizability with Otis, right? We kind of purposefully introduced Otis as a more or less black box solver, although you get a lot of control over it on the input side, right? Just with attributes and things like that. But now you can dive in. You have an editable subnetwork that you can actually plug pop forces and all kinds of DOP nodes into to drive more effects. And to take that even further, we have output of stress attributes, so you get all these different components out of it that obviously you can use in that subnet to drive more effects, or just externally to drive shading, wrinkle masks, all those typical things that you would use that for. But maybe the biggest improvement that we have quality-wise is the implementation of proper sliding constraints. So obviously things were already sliding over one another before, but this is an actual constraint that ensures that the surfaces keep touching, but can slide over one another, right? So because it was already sliding, the effect is fairly subtle, but in the middle you can see that, for example, the UV squares under the arms stay a lot cleaner because everything can slide around, and on the left it's maybe a little bit more stretchy. So we relied more on the skin deform, quasi-static skin sliding before to fix that. And here you can see that a little bit more clearly. So the pink layer is the tissue skin layer, right? And on the left is the only option we had before, where everything was rigidly stitched together. And we relied on the green, which is kind of the solid core layer, to slide over the muscles, which it still does on the right, but then we get this additional just level of detail and believability. And with that, we move to hair and fur. The big news here is that for the first time, we can really say that we have an end-to-end workflow for taking just any high-resolution static groom, be it from Houdini or somewhere else, without any special attributes, generate a sparse set of guides for it, deform the high-resolution hair with that sparse set of guides, after simulation, and then have all of that working at render time. So this has clearly been the biggest request for the past months and years on the grooming side. The first piece of this is the guide reduce SOP. So this is a completely new, written from scratch SOP, all in OpenCL, that has this adaptive algorithm that kind of magically picks the right guides that you want to simulate from the high resolution groom, right? So you can see it essentially picking the most unique hairs, like the one that you really need to be represented in the groom automatically. So all those stray hairs, if they don't have a direct representation in the guide set in the simulation, you can't really drive those with any other like nearby hair, right? You need those to be in there. And then as you increase the guide count, which is just a parameter on the node, it fills in more of the volume of the hair and eventually covers it much more densely, right? But we find that even with like 100 or 200 guides, you already get really reasonable simulations out of this. So yeah, on the deformer side, we have the guide deform 2.0, which uses the same sort of algorithm to then distribute the weights. So basically the mapping of the guide curve motion to the high-res hair, right? And what we're highlighting here is that all the stray hairs that you see flying away from the main mass, they all have a red guide representing them. So you get believable motion for those automatically, all with like default settings, no manual selections or anything like that. So here's a closer look at how the guide reduce works as we go in and grab individual hairs from the high-res groom. As they become like sufficiently unique, right, and diverge from the main mass, they automatically receive guide curves from going through just guide reduce. So this is the idea. This is the definition of these stray curves, right? You want those represented in that set. We get some more control with the guide reduce as well. You can select guides that you definitely want to be selected, and then the algorithm just fills the blank spaces around those. But even with all these improvements, there are still some remaining more subtle issues that you get as soon as grooms start to move. Of course, you usually sign off the grooms on like a static frame or a turntable where you don't really have simulation yet, right? And once you have an approved groove, everybody wants to keep that look and wants it to keep looking that way even under motion, right? But a problem we get as soon as the guides start to move, especially like tight clumps and things like that tend to spread out a bit and you lose a bit of the look. So to address that, we have this preserve shape and preserve clumps option. And it's actually a fairly big chunk of code underneath that runs a quasi-static physics simulation with stiffness and bend constraints all in this deformer. But on the surface, it's very straightforward to use, right? You just dial up some iterations, you dial up the bend stiffness and stretch stiffness, and it irons out a lot of the like high frequency remaining kind of artifacts that you get from the pure deformation. And then the preserved clumps make sure that the spatial relationship between hairs kind of stays as it was in the static room. So if you have tight clumps, hairs all coming to a point, it ensures that that really stays that way under motion. So here are some rendered results from that. We just made these different kind of clump styles to test it across various different looks. And you can see that it, without changing any settings per groom, it works really nicely across this these fluffy grooms down to like wet hair look or more clumped defined clumps. And so you can get started with this quickly and easily. We added this capybara sim and deform recipe. So capybara has a fur output now on his HDA. And this combines all the tools that I just went through in addition to this guide utility node, which takes away some of the like more mundane tasks like creating a roots group for pinning hairs to the skin, things like that. And you can see it's just a handful of nodes and it's really high performance, right? This was all playing back the Vellum simulation and the guide deform, everything at the same time. In fact, guide deform 2.0 refined is about 50 times faster than guide deform 1. So if you pay close attention, the bottom row is actually churning through some frames there, even though very slowly. And the bottom new node is running and comfortably running in real time on this case. So this is another one about preserve shape and preserve clumps. We can take this a lot further. Actually, this is what I would consider kind of a broken Vellum simulation, right? Some guides got stuck in the arms. We can actually just dial up the iterations on that to fix that in the deformer. We don't have to necessarily go back to the simulation. But of course, sometimes you will still want to fix the simulation. So we have new tools for that as well in the shot sculpt that we introduced last release. We have support for modeling curves as well now, and you can actually swap back and forth between those, right? In this example, I'm actually just painting a mask that blends back the pre-simulation guides for the quickest possible fix on something like this. But my favorite thing about it is that you have this combination, right? So you can go back and forth between modeling the mesh. The guides move with the mesh, then you do some fixes on the guides. Whatever you see, you just go in and fix it and go back and forth. I can go back to fixing some deformation on the elbow here. The guides just move with that fix. So it's just a one tool where you just go through the frame range and quickly fix all of the issues very easily. And then things like the masking that Shot Sculpt already had, that all works just the same with guides. You can mask off an area that you're already happy with and then go in and sculpt and fix the remaining issues like we do on the ear here. Yeah, and it's more generally useful though, right? We have this attribute painting ability with so basically animated attribute paint, you can think of it as. So we're using that here to fade in this styling effect where we change the hairstyle and the color, and I'm sure you'll find many creative uses for this, even outside of grooming. This is another look at guide utility. So here we see the roots group being created. We have the ability to snap guides to the skin, create the orient attribute needed by vellum in just the right way that vellum and both the deformer and vellum need it. And the normalized typical curve U attribute, normalized 0 to 1 value from root to tip, all in a single node, which really cleans up these groom and simulation networks. Yeah, and another big improvement we have is with hair generate, which now has a much nicer interpolation between guides. We brought in this blend in skin space option that you can blend in as a slider. And this is a prototypical example where this really helps a sparse set of guides on very highly detailed skin geometry. You previously needed to add a lot of guides to just basically help the interpolation along. And as you can see here, we can have extremely sparse grooms now that already behave correctly, right? So you're only placing guides where you actually need them for the look that you're going for. But of course, where you really want this deformation to happen is at render time. So we don't just have the guide deform SOP, we also have this configure guide deform LOP. We call it configure because it's not actually doing the deformation, it's just setting up an API schema that fully specifies the deformation, which is then picked up by a Hydra procedural. Super efficient, all C++ and OpenCL. And you can see that it takes very little configuration to get it going here. I just plug in the primitives for skin and guides, and you have deforming here. And I really want to emphasize like how tightly this is integrated with existing LOPS infrastructure. So, for example, we don't need the deformer to have its own geometry subsamples setting for motion blur. It's just whatever settings come in on the skin and guide curves, the deformer picks that up and lines up automatically, right? So you will hopefully never see, hair separating from skin geometry anymore, which is pretty easy to get with previous setups. But not to forget, we also updated the existing Husk procedural to support geometry motion blur. So this is a typical example where the velocity blur, which was really the only option before, kind of falls apart, right, on the right with 9 geometry samples. That just keeps working correctly.
Thank you.
Yeah, no problem. I know you've asked for it. Okay, so here's another example of how this integrates nicely with LOPS, into LOPS. So as we bring in the skin geometry, we just have an option to treat as subdivision surface or not, and the deformer just picks that up. It doesn't require its own setting. And here's an example of just basically the capybara recipe rendered and the whole process, the deformation happening in Hydra. And yeah, very efficient on disk space and network I/O. I don't have to tell you. You just need the static groom once, right? You don't write the groom data per frame. And here's our awesome chimp again. Really beautiful example of this all working together. Of course, not just the hair, but the hair, of course, millions of individual hairs, and I think 50,000 simulated guides. And what I really like about this close-up is that it feels like the individual hairs are simulated, right? But it's just a deformer, kind of everything coming together. The preserve shapes the quasi-static simulation, so you have some, like you're sprinkling some extra simulation into the deformer to get this nice individual deformation. All right, and with that, let's get back to Scott to tell you about modeling and terrain. Thank you.
Thanks, Kai. Okay, yeah, let's talk about modeling and terrain. So we've continued to improve the quad remesher with a lot of focus on quad flow. And it's particularly evident with our new method, this rectangular method, which helps especially on like hard surface models like this, where you have these very sharp edges, and you want to make sure the mesh follows those hard edges, which is actually a very difficult problem for quad remeshing in general. So as we look at a couple of these examples, you can see in the upper left there, the orange lines indicating where we've detected the hard edges, and then how the quad remesher is able to grab those and sort of constrain the mesh to those points, which is actually pretty tricky because obviously it can follow the edges, but then it also needs to make a sort of coherent mesh on the internal sections as well. And it's doing a really good job on these sort of CAD-like models, especially in places where you have things like holes and circles and things like that, where they're sort of the trickiest areas for a quad remesher to handle. And we're starting to do a really, really good job, and this new method does a great job solving those problems. But it's not just the hard surface models. We've also made improvements to symmetry, really important on organic models like this, where you want to make sure, along the line of symmetry, you have a nice edge flow that follows it. You don't get sort of warping and distortions. And we've actually found, pretty frequently that we're starting to get meshes that actually look like the mesh that was modeled. So if you compare this against, Craig's actual modeled mesh versus the quad remesh, it's actually remarkably similar, which is a great indication that it's kind of doing the right thing. Now, open subdiv, we've had that in the viewport for a while, but you could only really look at the surface. Now we're projecting the mesh onto the limit surface and allowing you to interact with the surface, to select it, select edges and points, and so on. So now if you're doing sub-D modeling in Houdini, it really improves the workflow by sort of getting something that you can actually visualize while you're working on it. So you can go ahead and make simple modeling operations like these edge loops. You can see how the subdiv is changing your model, or you can turn on primitive hulls here to actually see the cage and the sub-D surface simultaneously. So just a nice improvement overall for people who are working in this way, where instead of having to constantly switch back and forth, you can kind of stay in one place and continue to work. When you have a more complicated model, say like this keyboard, where when you subdivide it, you get a very soft edge on that leading edge, you can go ahead and add a polybevel, and then again, interactively see what the result is going to be without having to switch constantly back and forth. So just a nice overall improvement to subdivision modeling workflows and visualization in the viewport. On the idea of sort of workflow, here's a really nice tool from Side Effects Labs, just for splitting geometry. It has a whole bunch of operations that can be done to split up your geometry in interesting ways. And you can see as we sort of switch the method, we're getting an interface per method, but also we're seeing the vexpression there. So this is actually a neat tool because it is just a useful tool, but it also is showing you how these parameters and these expressions work together, which means that you can kind of learn how to do this as well. So it's a great functional tool, but also a really cool learning tool. We also have this utility node that is super useful called walk on surface. This is a problem that comes up all the time where you have some source points and you want to have the geometry move across the surface cleanly. So this tool allows you to set sort of initial directions so that you can have it slide across the surface, grow across the surface. Of course, it's Houdini, so you can use attributes to modify some of this behavior, like the length of the curve is moving across the surface. Or you can go ahead and change this method to a different method called streamline tracing, and then use attributes on the surface itself to drive the curve. So here we just have a sort of a noisy vector field, and then we're getting that noise represented in the walk on surface. It's amazing how often this sort of technique comes up, both in modeling and effects, where you need things to move along a surface cleanly, and this really helps you get there in a sort of very simple, direct way. And it'll work on any sort of closed mesh. Of course, you can pull attributes from the surface as well. Here's a really neat example where somebody created this sort of almost hatch-like or woven sort of version of the pig head, pulling the UVs from the geometry and the material properties and transferring to the curves to get this cool kind of look. Or for a more traditional problem, maybe you need to wrap cables around some geometry. So using the walk on surface and some detangle trickery, you can get curves that actually look like they correctly wrap around each other. They don't intersect, they slide over each other in a very believable way, wrapping this geometry, again, more of a modeling operation. On the topic, so of course we can do this for a lot of things. Maybe it's more of an effects tool. So here we have the capybara moving. We're picking up attributes from the curves to create colors. We're using a carve to carve it away. You can imagine using this for some sort of transition effect. Lots of possibilities for this tool. And on the topic of curves, we introduced a brand new curve tool a release or two ago that was really powerful. And now we've updated with curve animate. And so typically you might draw a curve and then animate the points, but this is a much more powerful version of that because you can animate the tangents as well as the positions of the points, which opens up a lot of possibilities. But more than that, you can completely break the topology. You can break the curve into pieces, change the tangents after you've broken them apart, and you'll see that we can interpolate across the full animation, keeping all the tangents coherent as well as the topology. So this is a really useful tool as it is, but you can imagine, shortly in the future with the idea of like having rotoscoping in COPS, for instance, you'd want a kind of a curve like this with a lot of control to animate it. But even in the short term, it's useful for standard sort of modeling operations. So here's just an example of going through these different shapes. And we're not just doing like a linear interpolation here. You can see that if that was the case, you would get crossover and things like that. So the animators actually made sure the shapes do not intersect themselves, which means you can do, almost the prototypical modeling approach of like revolving a curve and creating interesting objects. And having the ability to animate those curves really opens up the possibilities of what you might want to do with this for modeling or effects, as you'll see maybe a bit later. So let's take a look at terrain. So Kristen already mentioned that we're moving terrain and height fields into Copernicus. We took the first step on that with the solver in 21. So there's a couple of reasons that we've done this. First of all, a lot of the operations you want to do on height fields actually highly intersect with what you want to do for generating texture maps, for instance. Also, we've seen a big speed improvement, up to 5 times the performance for a lot of these operations by bringing it all into Copernicus. So here we are now inside of Copernicus. We have some presets to get a nice height field look by default. And you can see we've got some height field nodes in here, and some of them are actually just standard Copernicus nodes, and some of them are specific height field tools, which again bridges those gaps, right? It gives you a whole suite of tools that you maybe didn't have access to before or were more difficult to work with. One of the ones I personally like the most is the fact that in Copernicus, we get all the inputs and outputs as inputs and outputs on the node. So rather than shuffling layers around and dealing with volumes, you have a much more direct access to the tools. But you can see we've got height field slump. We can use that, one of the foundational tools for any sort of terrain. Here's the ramp editor that you saw before being applied to the terrain. Really, really useful for dealing with terrains when you want to very quickly start getting color on your terrain, very quickly want to sort of get an idea of what this is going to look like down the road. And on the idea of visualization, these are volumes under the hood. There's no mesh there until you convert them to a mesh. But sometimes it's useful to see the topology to give you an idea how things are flowing. So we've added a new visualization for height fields that lets you set sort of a stride length and show a mesh on these volumes, even though there's no actual mesh there. This is purely a visualization, and you can set the resolution of that. So you can still have a very high resolution volume and a low resolution visualization of the mesh itself, which is pretty cool. And one of the benefits, again, of having things in Copernicus is that all the inputs to your tools, like erosion, for instance, can just come from anything. In this case, we're just using ramps and gradients to feed into the erosion tools to change the direction of the flow. So you can modify the terrain, modify how the erosion works just by using standard compositing tools to create interesting direction maps. But it isn't all just porting things over. We added some new tools to get nice looking terrain. One of them is height field strata. And this basically sort of emulates the idea of like sedimentary rock or sort of layered stone. And it very quickly gives you like high detail across your terrain, which can be really useful, even in places where maybe there's not really sedimentary rock there. It just adds a lot of interesting texture to your terrain. And to help you get started with that, there's a recipe that works with both the strata node, and you can see slump used to put that sandy deposits in between the stones. Here's another example of these beach rocks created using the terrain tools. And this is kind of an interesting sort of bridge, right? Because it's like halfway terrain, halfway a texture map, basically, and really highlights how these tools can work together. And this is taking advantage of a new node, which again is sort of a COP node, sort of a terrain node called fractal sample. And what this does is takes your input and it samples it fractally, meaning that it uses it over and over again on itself at different levels of resolution and scale, allowing you to really quickly build up a complicated looking texture by having simple inputs, complex outputs, which is really, really useful. And here you can kind of see that it is a tiling texture as well. So this is another recipe that you could dive into to see how this tool is used to create this nice scene. And there are bigger scenes, more complicated ones that will be hopefully coming in the content library down the road that show you how to build much more complex environments with much more complex texturing to go along with them. Now here is neural layer to height. So this is really interesting for a couple of reasons. First of all, it's an ML node. It takes a photograph and attempts to estimate the depth. But what's really interesting is that this is using a third-party ML model, right? It's called Moge2. And this is useful for a bunch of things. First of all, when you put down the node, you can just download the model directly, and then it just works transparently in your network like any other Houdini node. And this is really important, right? Because the artist doesn't want to have to learn a bunch of different tools. They want everything to feel like Houdini. So this node drops into your network, downloads this model, then you have parameters, interface, everything you would expect from a Houdini node, except taking advantage of this ML model. So it really smooths out the workflow and makes sure it's not jarring to suddenly start using different types of tools. Of course, some of these models can be a bit soft, right? It's because it's just estimating the depth from a single photograph. So it's really nice to be able to still edit the mesh afterwards, edit the height field along the way, and add procedural detail that probably gets lost when you do this ML estimation of the depth. So, you have the ML input, but then still a procedural way of processing to get really high detailed results like this. And overall here, like I said, this is sort of a transition of a whole tool set into this other context, and all the advantages that come with it about having all of your texturing tools, all of your terrain modeling tools, all in this one context, and how they interact with each other and work together. How you can visualize the height now, how you can visualize the height with color, all in this very easy to use context. But of course, that's not everything. Once you've modeled your terrain, there's a whole secondary part of this, which is putting things on your terrain, rocks and bushes. Maybe you want, volumetric clouds. You need to turn that flat plane into like a fluid surface, right? And all this comes as a secondary step, oftentimes inside of rendering. So I'm going to welcome Rob up to the stage here to talk about Solaris and Karma and some of our new instancing tools. Thanks, Scott.
Thank you, Scott. It's great to be able to give you a bit of an overview as to what we've been up with Solaris and Karma. We've been pretty busy. I think what you're going to really see me talk about most, though, today is about our investment in layout, world building, set dressing, taking those beautiful landscapes that Scott talked about and populating them with content. And we know it's been a while. We've heard you asking for it. So here's some of it. Now, the USD component building workflow that you know and love from LOPS, we've now made this also a first-class citizen inside of SOPS. This allows you to stay in a single context for your modeling, your scene setup. You don't need to kind of go back and forth constantly between LOPS and SOPS, a very jarring experience. You can have proxies created directly from this brand new USD create component node, bounding boxes, convex holes, etc., or you can pipe them in from upstream. We have our create proxy tool, or you can use any modeling tool you want. Now, once you've got a set of components, or in this case, some subcomponents, you can start to build the parenting hierarchy of your scene and the initial layout. Again, still staying in SOPS, where maybe you're more familiar and comfortable. Each piece of geometry can be placed exactly where it's meant to be. And in the case of this sign, for example, we're going to want one on both the front and the back of the pole. So we can set up the instancing directly inside of this workflow at the exact same time. Now, the last thing I want to highlight here is the support that we have for both placing and manipulating pivots. And I appreciate that historically, it's been a bit of a challenge in Solaris. But hopefully with Houdini 22, that pain is going to be largely alleviated. Now, for the very art-directed placement of small to medium numbers of things, we've vastly improved the robustness and the feature set of our paint-based instancing. Brushstrokes can be used to add or remove objects, and we've added some basic shapes, some circles, some rectangles, that effectively get projected and then used as fill masks for, again, placement of these objects. You can still place individual objects as well, for kind of like with, for instance, control of rotation, scale, when you want something to be just here, just this size, just this way. What's perhaps more exciting is when you need more objects. And we've added a scattering procedural that runs Houdini engine inside of the Hydra rendering pipeline. Now, just like you saw with the hair deformation demos, being in Hydra means that these procedurals run identically, both in Husk and the viewport. You don't have to wait until the final render to see the impact of your work. Now, in the procedurals, we expose a variety of methods for masking the distributed instances to satisfy whatever your artistic intent might be. Maybe certain instances should only be on top of other objects. Maybe others should only be on the sides. And ambient occlusion lets us take that further. Maybe we want certain instances to avoid or prefer crevices or other shadowed regions. And as proceduralism means that you can change your scene. You don't have to bake any maps, but the masking will just react dynamically and appropriately for you. Now, camera-based frustum culling is another standard optimization technique to kind of make sure that your RAM doesn't explode underneath your feet. And you can use any camera here, so it doesn't have to necessarily be the render camera. And then lastly, we also support external geometry. So here we've got kind of point instances acting as, let's say, in a way, nested scattering. But you can also have these hero masks. So here we've got this cube for, again, just really kind of art-directed control over where you do or maybe don't want your instances to be. We saw it in animation, variety is the spice of life, and it's critical in selling the image. It really is the imperfections and subtle differences that make something believable to us. So we expose control across all of the components here for our transformations of these instances. We can have rotations that are biased up or down away from a global up vector. We can have random spin, random scale, slide objects just up and down just a little bit. It can be subtle, it can be drastic. We want you to be able to control that. And it's not just randomization. There's primvar support, texture map support. We really want you to feel in control of this. Now, I started by saying that this scattering procedural was for lots of instances. So let's move away from those few traffic cones and to this desert scene here, where we've got about 500,000 cacti and shrubs. Again, because this is a deferred procedural, the USD scene is nice and light, again, like similar to the fur. And it's all this data generated at render time. We can use our point instancer masking to make sure that those kind of shrubs don't get too close to the boulders. We want the ground to be a little bit more arid in that region. And then we can also use that hero mesh masking as well to introduce a road here. We don't want the vegetation to be on the road and right around the edges as well. We want a little bit of a soft fall off. And all of that is achievable with the controls that we've given you. Now, one last bit of layout that I really want to call out is the edit lob. And this is a tool that previously was used primarily for the manipulation of single objects. But building on work across Houdini related to RBD and ragdolls, physics-based manipulation of entire scenes in Solaris is better than ever. By dragging and scaling clusters of objects, you can move things around in really interesting organic ways, creating plausible piles. And this is really iterative and interactive workflow. You can refine your selection and move things around again and again. And as a segue to rendering, we now have support for instance mesh lights in Karma, with per instance, per bulb in this case, control over things like intensity and color. So let's carry on that theme a little bit. Lighting and volumes in Karma has been significantly improved. Let's kick off a live rendering session and explore this particular setup. And this is the type of image that you would get out of Houdini 21 today. I mean, it's not bad for a sub 10-second render, but we lost that bright core of that point light up at the top, and honestly, it's pretty noisy. So what would we do? Well, in Houdini 21, we can crank up the color limit. And that allows us to regain the point light definition. But the noise is still there. If anything, the noise is even worse than before. So in Houdini 22, we can reset the color limit and instead use a new control for equiangular multi-importance sampling on lights, which gives us both the shape definition that we want and, as an added benefit, less noise. So let's again compare these three images. They're all sub 10-second renders. Houdini 21, cranked color limit, Houdini 22 with the new equiangular MIS. This, I think, is going to be really, really handy for a lot of effects. Now, for the ultimate direction in light placement, we also now have light blockers. And this is somewhat similar to the instance masking that I talked about with scattering. It allows for really, really controllable zones for where light should or shouldn't be allowed. And we expose a variety of controls for you to change the shape of the object, the size, the soft fall off, a few other things as well. Now we're going to switch to look depth, so I want you to cast an eye on the ground plane in this scene, because I want to talk about the new texture material library, LOP, that we have. It allows for a much smoother workflow for COP-based material editing, building up procedural textures and seeing the result immediately, either in the render or the COPS view. It really depends on kind of which is more useful for the task that you have at hand. What I want you to really take away from this is the tight loop that we've built between COPS, texturing, rendering. All of this is working together in one place without that previous jarring experience that you would have of needing to jump between contexts. Now, as with every new release of Houdini, we've moved to new versions of both USD and Material X. And moving to the latest Material X version means we now have this gorgeous flake shader supported in Karma. And it can be used for a variety of effects. Now, it's perhaps subtle in this particular render, but we've also introduced a new Karma-specific shader for both curvature and ambient occlusion, something else we've heard you asking for. We previously had slap comp, which could be set up in the viewport UI. But in Houdini 22, we've moved this into LOPs, into something we call image filters, which allows for USD-based authoring of post-processing effect stacks. Now, we're not exposing all of COPS here, but there should be more than enough to build up some pretty radical or some pretty subtle of changes. And each of these filters, of course, comes with its own suite of parameters, ultimately giving you, the artist, more control in pursuit of your vision, or that of your client. And because this is all set up in Solaris, everything is authored as USD data. It means it can be further modified, post-processed, saved as a studio library, really whatever you want to do with the data. Now, we appreciate not everybody uses Karma, and so image filters are available to all renderers. Here we'll enable RenderMan in the viewport and turn on the filters. You can see the result is a live effect, not only as the render proceeds, but also if you choose to do further work elsewhere in your scene. For example, here we're going to do a little bit of layout refinement, and the filters just continue working. Now with that, I hope you're not sick of them, because I'm going to pass back to Scott again for the next layer of this onion, VFX.
Okay, thank you, Rob. So if you've been following Houdini for the last couple of releases, you'll know that we were at sort of a breakneck speed adding new solvers, sparse pyro solver, NPM solver, sparse cop solver, ripple solvers. It's almost endless. And so we took this release to sort of slow down, catch our breath, and say, okay, let's make sure we're actually making sure these workflows are coherent and fill in any gaps that we may have missed along the way. One of those being that Bullet was missing an easy way to set up bending and metal fracturing, which is a really important effect. Now, of course, you could use the NPM solver for this, but it can be overkill for some effects. And also, many people's pipelines are really focused on RBD and Bullet. So this gives you the option to have this type of effect without having to maybe go to extreme lengths of something like NPM. We also took, one of the workhorse of fracturing tools, which is Voronoi Fracture, and we've sped it up drastically. It's 3 times faster now than it was in previous versions. So then when you're creating scenes like this and you have to create maybe hundreds of thousands of pieces, you're not waiting just on the fracturing part. You can get more quickly to the actual simulation part. We also added some recipes for, standard sort of magical effects like this. With the idea of being just showing people how to get from simulations to renders to compositing, all in one recipe as a learning tool, but also just like a usable magical effect that you can customize and use on your own. But one of the big focuses was the Copernicus-based sparse GPU solver. So in the previous version, it was introduced, but it was a highly simplified solver meant for simple effects, background effects, things like that. But we wanted to make sure this was improved to be a full sort of production level fluid solver. And so what you can see here is, first of all, a Copernicus network, but also the quality of this matching what the SOP and DOP versions are. And to help this, we also created some new interesting inputs to the solver, one of them being called implicit surfaces. So implicit surfaces are sort of descriptions of shapes that can be used to model complicated shapes, but also act as collisions and sources. And the very important reason for this is to do this on the GPU rather than creating a mesh and then uploading it, which causes a performance hit. So these implicit surfaces can be created and then evaluated on the GPU. They were used here for the ground plane in this cup. Of course, you're probably looking at this and thinking like, wait, I've seen some of these examples before. And that's kind of the point, is that these are the samples that you've seen before, except rendered and generated inside of Copernicus, right? So Copernicus now is matching the level of the SOP solver, the DOP solver, with all of the benefits of being inside of Copernicus, where you can immediately start doing interesting things post and pre simulation. So we've replicated all of the underlying effects just to prove that they're there. You can use these as learning examples as well, because at the end of the day, it is a new setup and a new solver. It'll take a little bit of time to catch up to how things work inside of Copernicus, but we think the workflow is greatly, greatly improved. So speaking of Copernicus, let's take a look at some of the features here. Now, Kristen has mentioned that, this has started out as essentially a texturing environment, and we really feel like it's highly matured now. It's really a functional tool that can be used for any sort of texturing, but we still have things to add. So here's an example of something called UV shape, and we're just putting a checkerboard on here for the visualization's purposes, but the idea is here to give you handy UV layouts that you can use for your texturing approaches. Of course, these are not just static layouts. They can be used for all sorts of interesting things that are kind of difficult to set up by hand, like these horseshoe UVs, these spiraling UVs, or in the bottom right there, this sort of overlapping sort of fish scale UVs. And like I said, these are parameterized options. These aren't just like static things that you put down. There are options for all these different patterns. You can modify them and then use them to create, detailed, interesting patterns like this interesting sort of mother of pearl kind of effect, or more difficult to create things like this loxodrome spiral effect, which again has a ton of parameters for affecting the shape. And basically you just sample these UVs with whatever your input texture map is to spread them across the surface to create these really interesting shapes, which of course can be animated and used for all kinds of cool effects. Here's just an example of these seashells that were created along with some other tools like fractal sample and height to caustics. We'll get to you in just a second. We've also added procedural grunge maps, so you have things like drips and spatters and stains and rust, tools for creating weaves and knit patterns, bark patterns, all the things that you need when you're trying to create a realistic set of physically based rendering texture apps. Here's a really nice example of sort of cloth and wool materials created using these new tools, and you can see high fidelity, extremely realistic results. For those of you who are working in game engines, we've continued to work on session sync. Here's a Copernicus network being used to drive an Unreal material, which is super useful, especially the sort of interactive live back and forth between the two engines. Here are just some examples of them being rendered in Unreal. Of course, they look awesome. In the previous version, we had a lot of new tools around baking, so in Karma and in Copernicus. One of the issues that comes up a lot with baking is that when you have a cage mesh, oftentimes there's things that you need to debug. You need to see like, oh, my high res and my low res mesh are maybe interpenetrating each other. You need tools to identify those problems and fix those problems. So we have created a bake pre-process node, which works in the Cop Baker and the Karma Baker, that helps identify and fix those problems. So you can drive the position of your cage mesh using attributes, and a number of other methods to help fix those problems before you get to the baking stage. Here's just a cool example of that same model baked down now and shown in Unreal and showing the nice high fidelity bake you can get from that geometry. Continuing on, planar inflate. Here's a really interesting tool that takes a shape and inflates it. Inflates it in 2D here. So you can see this heart being sort of inflated from the 2D plane. But we can also add interesting details on top of it, like wrinkles. You have a lot of control for the look of the wrinkles. You can add sort of distortions to the overall mesh, to break it up, make it look less uniform, as well as some options for sort of blurring and masking these out to create almost one of those sort of foil balloon looking textures. But in a more practical case, you can actually do this on like a character, for instance. So here we have sort of our Badger character wearing this spacesuit. And by isolating the UVs that represent the cloth parts of the character, we can use planar inflate to add, detailed wrinkling along all the edges and the seams to give you something that, doesn't require any direct user intervention. Nobody needs to sculpt this detail. You can procedurally generate it for any sort of changes to the underlying costume, which is pretty cool. Here's another interesting example called neural cellular automata. This is an ML node that basically takes an input, which is a sample of a texture map. The ML is trained on that texture map, and then it learns to reproduce it. And it can reproduce it at a bigger scale and add interesting distortions to it as well. So let's take a look at sort of a closer example to make this a bit more clear. On the left, you can see the input textures. And then in the center is basically the ML attempting to learn how to recreate the texture map that is the input. But of course, just recreating it is not necessarily that useful. You want to be able to do things with it. So you can see on the right how we're able to rotate, we're able to affect that texture map and make sort of a new repeating texture from it. And where this gets really interesting is that you can do this on 3D geometry as well, taking advantage of something called adjacency, which we'll talk about in just a minute. So you can actually grow these maps over the surface of your 3D object to create seamless three-dimensional texture maps that interlock in this really cool way. And of course, you can do interesting effects by blending between these models as well. But what about when you need to do something by hand? So in Houdini 22, we're introducing Paint 3D Comp. This is a paint package, essentially, inside of Copernicus. Here you can see we're sort of drawing these stones, but what I really want to focus on is some of the usability here. We can turn on tileability so that you can create a seamless texture map. You can see that on the left, we have a layer stack with blending between the layers. At the top, you can see we have alphas and brush shapes, and we have catalogs and recipes for those so that you can have all of the brush types that you might want. On the right, you can see that we have a lot of options for adjusting these, like adding randomization, adding things to the flow and to the stroke shape. And it isn't just in 2D. You can do this on 3D geometry as well. So here we have this kind of cartoon chest, and we're just painting some sort of cartoonish sort of wood grain onto the sides. So this opens up a ton of possibilities for directly hand editing texture maps inside of Houdini using standard sort of painting tools that you would expect. And pretty quickly, after noodling around for a while, you can create a fun sort of cartoon chest or this sort of wet rock texture that you see on the left that tiles really nicely. But it isn't just painting, of course. You can use this for anything. It just lives in your COP network. So here's another example where we're using masks that were painted on this sequence of images here. I think there are 10 masks where we've painted out an area on this backpack. And then we're training an ML model, in this case using Detectron, and training it using PDG. So essentially we give it frames with the mask painted on it. The model learns how to find the thing that we've masked out in the image, and will generate the mask across time. So, with I think it was 10 frames of input, we can get a full sequence of this texture, this sort of mask, I should say, following the image, because the ML has learned to detect that place, those parts of the image, and continue to mask it out over time. So there's a lot of interesting possibilities along these lines. Here we're using another third-party model, SAM2, which is image segmentation. You can see it's like finding the mask based on like what the image looks like, what the objects in there are. And again, these ML models are really interesting, but I also want to just remind you of like how integrated this is inside of Houdini, right? It's grabbing this model, but the interface looks like Houdini. The inputs and outputs are just Houdini outputs, so you can seamlessly integrate this into whatever texturing or compositing pipeline you might have. So some oceans. Obviously, we've had an ocean suite of tools for some times in SOPs, but that was targeted at effects, rendering, large-scale oceans, tons of customization, integration with fluid simulations, and that sort of thing. This is the viewport, just showing a COP-based texture map, which means basically we're outputting height and cusp, as you would expect from these tools, as texture maps. But of course, you can do effects-like things with them if you still want to. Here we have a COP block running a custom phone simulation. So you can build these sort of texture-based simulations inside of Copernicus, taking advantage of the new context options as well to add some modifications within that block. And you can see we can get a pretty cool simulated foam result and then combine them together with the ocean to take sort of a nice sort of cusp rendering and add the foam on top. Of course, you could use this for a render. There's no reason you couldn't use this for a render. It's just going to be probably a tiling smaller patch, but still useful. Or maybe you want to take this into a game engine and use these maps as like an animated texture map to drive something else, or just distort a surface that way. And since we're adding some of these tools, we want to add things to make them look more realistic as well. So here we have refract from height. And what this does is takes a surface that represents the surface. In this case, it's like an ocean surface. And then we take depth, which represents sort of what's behind it. And you can see as the checkerboard recedes in space on the left, we see that represented in the refraction, giving you a very plausible refraction in 2D without any sort of rendering happening. Along those lines, we have caustics from height, which takes the same kinds of inputs. You've got a surface, you've got a floor, essentially, and how those caustics would be projected onto that floor. And you can see, very sharp caustics on the right, and then sort of soft, diffuse caustics as the floor recedes on the left side of the image. Again, giving you this very believable result. You can see dispersion happening. You can see the color banding that you would expect from caustics, all in this sort of simplified 2D workflow. And as you start combining these tools together, you start to get really believable, interesting results with caustics and refractions. And earlier we showed you this modeling scene, but here it is with these tools. So what the artist has done here is something very clever, which is to basically render out through the camera's perspective a depth map, and then use that with the caustics from height to create a caustics map, and then reproject it through the light to create this very believable caustic effect, but very cheaply done. You don't actually have to render out the caustics. So there's lots of ways that these things can be combined together, and it's kind of one of the goals of all of these tools is to take all of the elements of Houdini and have them all communicate together. We've talked about how Houdini is, Copernicus, I should say, is a mature texture synthesis environment, but we're moving towards compositing. And here's just some examples of like a fluid sim here on the glass, but all the refraction stuff, that's all happening using refract from height, right? So we're, again, not paying the cost of going to a full render for this, but still get very believable results. Here's a really cool example of many of these things working together. It's just a really fun animation taking advantage of all those kinds of effects. But there are some new solvers as well. So here is a ripple solver, a 2D ripple solver inside of Copernicus. Again, can be used for actually distorting surfaces, maybe at final render time. They take animated inputs for like causing the ripples, but also have collision objects like you see on the left. And again, as you start combining all these tools together, you start to get really interesting results. I can imagine a lot of uses for this for non-photorealistic effects, or even sort of motion graphics-y sort of effects, because very quickly, even just combining a few of these things together, you can get a really fascinating, mesmerizing sort of result. Or maybe you just want to do it all in Copernicus. You're going to have these fish swimming in this fish pond, and add rain, and add a custom rain simulation to make the surface become wet, and use the light cop to bring out specular highlights on these 2D images. Everything here was done in Copernicus using the tools that we just talked about. Here's just a small sort of breakdown of the ripple sim that you see in the top left, the custom rain solver on the bottom left, and on the bottom right there, you can see the light cop being used to add specular highlights to this fully 2D image just based on the height alone. So again, tons of possibilities for pre-processing, post-processing, or just directly using all of these effects together. Speaking of that, earlier we showed walk on surface, and here it is actually being used with Copernicus, with Karma, to take stamp points, sprite instancing, using the points from the walk on surface to create this sort of transition effect as the capybara walks through some sort of 1980s synthwave environment. In the 80s, they didn't have fur rendering, and that's why he doesn't have fur, but eventually he'll have fur as we catch up. But something you'll notice here is that as we're doing this, it's perfectly seamless, right? You're not seeing, obviously the capybara is UV'd, he has UV seams, but where are they? So earlier I mentioned adjacency. And this is a new technique that we're using to avoid these problems. So on the left, you can see the ripple sim running on this sphere that's been UV'd. And when it hits the UV edges, of course, the sim doesn't know what to do, right? The sim is 2D, it hits the edge of a boundary, and it just continues. It has no idea that it should actually transport itself to some other part of the texture map. But on the right, it's seamlessly crossing those borders. And that's being done by something called adjacency maps. And what we've done is helpfully bundled these up into a cable for you, so you can just plug them into any adjacency-aware node. But basically, this defines what happens when something reaches the edge of a UV tile. How does the vector need to be transformed to line properly with the other parts of the UVs? So if we look at it here on this like 3D model, we're just distorting these nodes using distort with adjacency. And on the left, you can see when there's no adjacency, those red areas appearing. And that's sort of a visualization to show where we're pulling in data outside the UV islands, right? The space between the UV island. And you would get this. It would either show up not necessarily red like this, but you'd see stretching or weird seams that you couldn't get rid of. Whereas on the right, the distortion, even though it's quite extreme, remains coherent across all of those seams. And that's really important for this kind of work. And you can use this for a lot of things. You can sample, for instance, this mask where we're masking out a direction where maybe rain is hitting the character. We're using that to mask out a custom simulation where we have the rain particles sort of hitting the character and sliding across the surface. Again, seamlessly sliding across the surface. So the stuff from the chest and the legs and the hands, doesn't hit any of those UV boundaries. And then we can use that directly in the full texturing of this badger character to make it look like he's being hit by the rain and slowly getting soaked over time. And this is really interesting for the adjacency part of the equation here, but also the reduction in complexity. A lot of times this would require some kind of special shader, right? That's going to pull in a point cloud or do something along those lines. But this turns it into a texturing problem, which is much simpler, much easier for the artist to work with. And it puts it in the control of the texturing artist rather than having to go through a larger part of the pipeline to get this kind of result. And so we've included, multiple tools that are adjacency aware, and one of them being the cellular automata. So again, on the left, you can see that as the growth begins on the hands, it almost seems to arbitrarily appear on different parts of the mesh. Because again, if you imagine this is happening in the texture map, as soon as it hits the edge of a boundary, it just keeps growing, so it'll show up to whatever the nearest UV island is. Whereas on the right, it grows smoothly from the hands, up the arms to the shoulders, across the chest, and so on, just as you would expect it to, right? So again, this opens up a ton of possibilities for texturing, but also, I think, really interesting effects. You can imagine using this with a particle effect or a fluid effect to create a really interesting sort of growing pattern on the surface of this character. In fact, here's an interesting example combining a lot of the things that we've talked about: the ripple solver, the reaction diffusion solver, adjacency maps, even time shift, which we don't have time to talk about today, but we've introduced the concept of time into Copernicus. So tools like time shift that you're used to working with in SOPs now exists inside of Copernicus, letting you, line up all these effects in this interesting way. And now Gaussian splats. You've seen them throughout our presentation. They're used in all sorts of different examples. And we want to talk a little bit about, the underlying processes that are happening here. So first of all, let's look at this example. On the left is Houdini 21. On the right is Houdini 22. This is a Gaussian splat of this city environment. You can see obviously 22 has much better performance, especially as we start zooming in. It's important to know that there are 23 million points in this Gaussian splat, right? So there's a lot going on, even though the city itself maybe looks simple sometimes. There's quite a lot going on. We really focused on getting quality and performance for G-splats in the viewport, which is really important. You've already seen this example of the wasp being rigged and deformed. And again, that comes down to the fact that really under the hood, G-splats are points with attributes on them, which means they're a perfect thing for Houdini to manipulate. Here's an example just to really drive that home, right? On the right, you see the test geometry for the capybara, which, by the way, now comes with a full groom and a full G-splat of the capybara, and that's what you're looking at here. This is an animated G-splat, and we're animating it just by using bone deform and surface deform, right? Just standard Houdini nodes. Nothing needs to be G-splat aware necessarily. So we can pull it in, we can manipulate it the way you would expect. And that includes, things like simulations. We can make this palm tree very believably sort of move in the wind by adding a simulation and driving those points with that simulation. Now, G-splats do have a problem, right? It's sort of a benefit and a problem, which is that it has this incredible ability to have the lighting baked into it that's view dependent. But that does mean that if you manipulate the points too far, the lighting starts to look weird, right? It doesn't quite make sense anymore. So you need to be really careful about how much you distort them. And we really want to try and address that problem, but it's a very tricky problem. However, we've introduced some tools from Side Effects Labs here, which are sort of prototypes for relighting Gaussian splats. This is a bunch of tools that do many things. First of all, they delight the Gaussian splat. They sort of generate some surfaces. They use the normal information and Copernicus to actually create a relighting scenario on these splats. And you can see the results are already getting really good. So we're really going to keep pushing this in the future. And we found some interesting techniques. Here we have spherical harmonics. You can see on the right how nice those wings look as they get backlit by this new light. And you've seen this WASP a bunch of times now. Obviously, this is completely different than the baked-in lighting that you saw earlier. And obviously, we want to be able to render these things. So we could do this in Karma XPU in the previous version, but we've basically rethought our approach to that. So in 22, it's a whole new approach with a focus on quality, because the results could be quite noisy, took a lot of time to resolve, and that's much, much better now in Houdini 22. And you can see the fidelity is really, really excellent. But, you know, Vulkan is no slouch. You know, this is the viewport showing us that relit Gaussian splat. And the quality we're trying to get here is something that we're looking at in the future as we start walking towards, you know, a cinematic real-time renderer, turning Vulkan into something that would generate sort of final pixels. But we still want to be able to do more things with it. So, you know, we've got this, the WASP again, lit by this HDRI in the background. And of course, we can take that into Copernicus. Why not, right? So we take the Karma render, and we treat this as a slap comp problem, right? And we can add some basic compositing like chromatic aberration so that everything stays interactive. I'm rendering this G-splat, I'm relighting it, and I'm seeing the composited result, which opens up, I think, a lot of possibilities. You know, we're still exploring this space. But where do we get them? You know, how do you get G-splats? So here's an example that we generated inside of Houdini. And in this case, it's generated from photographic inputs, right? So let's take a look at that process. So first of all, I want to be really clear about something. There's a step to this process that we are not yet handling, right? And that's something called a COL map, a call map, which basically estimates the camera from each photo and estimates sort of a correspondence between those cameras. But once you've got that, you can use PDG, you can use TOPS to train the G-splats inside of Houdini, taking advantage of the parallelism that you get from TOPS to do that. So you can generate them quite quickly, say, on a render farm. And we have some tools to help you understand the process here. Here's one of the monitors, so you can see what the ML is doing as it processes these photographs over time. You can see sort of the number of points being addressed and how it changes. And honestly, it's just really cool looking to see how the G-splats evolve over time, how they get sort of clearer and clearer as the ML is able to find the correspondences between all of these points. And again, because this is Houdini, there's no reason you can't set up a very simple network to clean up your G-splat. Quite often, you get a lot of sort of junk around the periphery when you generate G-splats. But you can see the fidelity we're able to get. You know, you can zoom way in on this workbench, and you've captured all the lighting, the reflections, and the detail in this sort of workbench area. And then we want to take it into COPS. We want to be able to do things with this. So we have a couple of new features here. First of all, we have a camera cop, which is new in Houdini 22. So you can work with cameras inside of Copernicus. But we also have a rasterized G-splats node, which means taking your 3D G-splat and rendering it into 2D, essentially. And from that, we can get some useful information, obviously the color, but we can also get depth, right? So now you can start to do sort of traditional compositing style effects on a G-splat, because now it's essentially a 2D image. You basically sort of rendered it, rasterized it into 2D. In this case, we're just doing a really simple color correction of the background just to kind of show how you can manipulate these G-splats as you would expect from any other kind of 2D image. But what about, you know, we live in a world of visual effects, of like rendering, of Karma. What happens when you want to do this not from photographs, but from 3D renders? So here we've taken in this mesh. So this is a mesh, it's not a G-splat. It's a standard sort of Karma render of this small sort of environment. But we can take advantage of some of our G-splat tools now to do something really interesting. We can replicate that process of walking around with a camera and taking a bunch of pictures by creating this array of cameras around our scene. And so very similarly, we don't need to go to a third party now to create that estimated camera, because we know exactly where the camera is, right? We placed it there. We know exactly where it is. And more than that, we know a lot of really useful information that you don't get from a photograph. We know exactly the position of everything in our scene. We know exactly the normals of everything in our scene. We can use that while we generate these G-splats to pull out information that can be useful down the road. You know, for instance, we have maybe position. Maybe we want to look at the normal information, right? All this is in the G-splat now, right? And suddenly you have a whole bunch of potential that you didn't have before when you were working from, you know, purely a photographic approach. Here, example now of the same scene, except this is the G-splat version of it. And you can see it's almost indistinguishable from the Karma render, right? Except this is a live, real-time scene that you can tumble around. And just to really drive home how much fidelity you can get out of this, here's this character, this furry cat. You can see the reflections, even the refractions in the eyes, even though this is really, again, it's just a point cloud under the hood, right? But look at the detail you can get in the fur. And as we zoom in on the ear here, you can see the fine, fine detail there, right? You can capture high fidelity models and replicate them in full 3D in a real-time environment. And it's not just meshes, you know, you can do this with volumes as well, right? So this is a G-splat version of this cloud. And honestly, to me, it looks stunning. You know, the fact that this is running in real time, you can tumble around this, you can see the backlighting, all the information you get from volumes in the viewport, of course, able to be rendered as well. I think this is going to open up a lot of possibilities for like set dressing, you know, hyper-realistic proxy objects for laying out your scene. Maybe you want to get examples of effects, right? So here is one of our fireballs that you saw earlier now generated as a G-splat by rendering this frame from multiple points of view. So let's take a look now at sort of a comparison. You know, on the left, OpenVDB, Karma rendering frame by frame. On the right, an animated G-splat. So obviously the left, 180 megabytes per frame. On the right, 45 megabytes per frame. So a big reduction in the overall memory. But there's a trade-off, right? On the left, what you see is what you get. The camera was there, we rendered per frame, that's the result. On the right, you know, it's a higher cost to generate a G-splat. Every one of these frames needs multiple points of views, right? So the rendering cost is much higher, but the result can be used over and over again from any angle, right? So it depends on what your workflow and what your goals might be, why you might want to use these. Or even more so, you know, maybe you want to take this elsewhere. Maybe you want to go into a real-time environment. So here's just an example now, playing back this G-splat, kind of just proving that this is, again, a point cloud at the end of the day. And more than that, we can interact with this, right? I can tumble around this in real time with the same fidelity you get from the full render, but now in this real-time environment. So I can imagine a ton of ways this might be used. You know, maybe you want to place these in the background. Maybe you don't want to pay the cost of rendering that every time. You pay one big cost and use it over and over again when it's needed. So thank you very much. I'm going to bring Rob Stauffer up to the stage to finish off our presentation. Thanks, Rob.
Thank you, Scott. We're almost done. So is Scott's voice, I think. So don't ask him any questions later. So the complete list of features, as usual, is always long. We couldn't cover everything today. Among the features we're leaving for you to discover on your own are things like the mask combine cop, which generates new textures by blending baked textures very easily. Scott talked a little bit about the time shift support that is now in COPS. There's some sort of less glamorous enhancements that, you know, are also very important. Among them are Linux ARM support or Linux ARM build that you can use on your render farms. Some cool improvements to the geometry spreadsheet UI, like being able to add custom columns. Here's some more. Overall, we hope the release offers you something that inspires you to dig in, break it, abuse it, and enjoy Houdini 22. And as always, I want to thank everyone. I want to thank our speakers today, everybody from R&D to sales to marketing to the TC team, support, labs, everyone at Side Effects, all of our external partners, people that helped with the content you saw here tonight. And yeah, thank you all for coming, and I hope you enjoy Houdini 22.